So here we're going to look at the history, if you will, of programming languages. We're going to start with the first generation language. That's the 1GL, first generation language, is machine language. Now, machine language is not human readable, but it is the language that is understood by the CPU. In an earlier domain, we looked at applications that spawn processes and processes that spawn threads. And those threads are the instructions that the CPU can execute directly. Well, that thread is written in machine language. So machine language actually provides a couple of different things. First, it secures the intellectual property of the program because it's not human readable. But that's the downside of it, is that it can't be modified when we need to make a change or when we're in development stages. So again, 1GL is called machine language. It's not human readable, and in a way it's a form of encrypting or securing your intellectual property, your program. The second generation language is called assembly language. Now, assembly language is very rudimentary, very basic, and it used 8 bits per byte, but it also had to be translated into machine language. Now, assembly language to the skilled, to the trained, was somewhat human readable. So it was written by humans. The code would be written by humans in this hexadecimal representation, and then would be translated into machine language. And the software that translated the assembly language code into machine language was called an assembler. So this assembler program actually interpreted the assembly language into machine language. Where we are right now is at high-level languages. We are in the 3GL, third generation languages. Now this is where we have BASIC and Fortran and COBOL and C++ and C++ and all the others. And we actually are moving closer to fourth generation language. So we're somewhere about 3.5 GL is what most people say. We write our programs in higher level scripting languages where a specialized syntax in a command actually implements more than one instruction at a time. It could be approximately a whole procedure that is tucked into this one script. So again, we're working on high-level languages. Now again, these are written in scripts. So again, this is a human-readable form. Again, it can't be processed by the CPU directly. It has to be translated or interpreted into machine language. So I will either run the script through an interpreter while I'm in development stages, so that every time I run my script it gets interpreted on the fly and gets fed to the CPU. Or I can compile the script once I'm done with it and I'm satisfied I want to lock it down so nobody can make any changes to it, and also nobody can read any of the code. So I will compile it, and now it is permanently translated into machine language. Again, it's not human readable. It is now the executable that we see on our computers. 4GL is fourth generation language. This is considered very high level language, very abstract, and we aren't quite there yet, but this is where we're dealing with large components of software that get strung together more along the lines of higher level object-oriented programming. We're not quite there yet, so that still has to be defined what 4GL truly is, other than it's higher than where we are now. And then fifth generation language is the actual natural language, where a human would say, computer, I need you to balance my checkbook. And the computer would actually automatically generate its own code, understand what you said, generate its own code to actually perform the work that you've requested. This approaches artificial intelligence. So again, this is where ultimately we hope to be going. We're approximately at about 3.5 right now.